Hello, everyone. How are we doing? Um, Welcome to the inaugural Tech Tips webinar. We've started this webinar series to start sharing out interesting workflows and deep dives into specific features across our Geomagic portfolio. You're obviously here, so you've signed up to our Tech Tuesday mailing list or found this invite through other means, but we will be running webinars very similar to this every month this year. If there are specific tools or features that you want to see in webinars moving forward, then reach out to us. I will add an email address into the chat or reach out via LinkedIn or over YouTube or anything like that. We will keep an eye out for ideas. We want to serve you content that is going to be useful, so any feedback is very welcome. If you've got any questions as we go through the webinar, then use the questions function on the GoToWebinar control panel. If you've got any other chats, then feel free to reach out on the chat function as well. I'm Guy Buttle. I'm the product marketing manager for Geomagic, and I'm going to be the MC and host for these webinars. With me is Sean Parker, one of the AEs based in the US. I'll pass it over to him so that he can give you as much or as little information about himself as he wants to.
I like to try and keep it vague and stay kind of incognito there. Hopefully you guys can hear me okay and you can see my screen all right as well. As Guy said, my name's Sean Parker. I'm one of the senior applications engineers here at Oqton. And today, I thought it was Tech Tip Tuesday. It's actually Webinar Wednesday, but I'm a little bit off here. But we're here to talk about selective surfacing, which is not exactly a tool per se inside of Design X. It's more of a mode within the exact surfacing or auto surfacing command in Design X. But it's kind of a pretty cool tool, and I think it's not really either appreciated or understood or utilized quite as much. So this is kind of my deep dive into a less utilized but still really cool feature in Design X. So what the exact surfacing, selective surfacing option does for us is it allows us to not use the auto surfacing command on the entire mesh, essentially. Basically, choosing what areas of the scan to ignore. Guy, you just went away there. Let's see if I can get rid of that. There we go. Okay. So yeah, just ignoring certain features on your mesh, surfacing or exact surfacing, auto surfacing a portion of it, and then coming back in later on with some other tools, more prismatic kind of traditional modeling, CAD modeling tools to finish the rest of the model. So I've got a few examples on the screen here. Something's weird is happening with my PowerPoint, so it might freeze my computer when I try and exit. Oh, no, it actually is working today. That's good. Just to kind of give an example of why this selective surfacing operation is useful, right? So I've got a selection of parts here. A lot of them are either casting or forging, or we see a couple of topology optimized parts on here as well, and they all have a couple things in common, right? There are mechanical features like a lot of holes, counterbore holes. On the axle down here, we've obviously got tubes and spring perches and that type of thing. And those are features that we really want to control dimensionally and positionally with more prismatic kind of normal CAD modeling tools. But the rest of the parts are very organic, generally speaking. While some of them, like some of these cast parts here, could potentially be modeled with a more traditional history-based approach inside of Design X, it's very time-consuming. And in a lot of cases, the people that are reverse engineering parts like this really don't care to make any changes or make those surfaces in these organic areas editable, right? Especially if we come out of a topology optimized, generative design software, we really don't want to change any of this stuff, right? The shape, size, and taper and everything of all of these little arms here or whatever has been dictated to be exactly that shape for a reason, for functionality. So we don't really need to make any edits to those areas, but we certainly do want to, make sure that when we align or orient or assemble this, component with other things, that we don't have surface patches in areas that are more prismatic, right? So, auto surfacing is a great function inside of Design X, and a lot of other software out there has it. RAP and Geomagic for SolidWorks, some of the competitors also have it. And it's great for shrink wrapping very accurate surfaces over the scan data very quickly, and especially in areas that are challenging to model or just completely, pointless to model. Not something that we really need to be spending a lot of time on. But we understand that every one of those individual surface patches is a freeform, and this is still going to be a solid body inside of CAD when I move this file into SolidWorks or NX or Mastercam or whatever it is. But really, the gold standard is analytically perfect surface planes and cylinders and cones for those types of features, right? So that's going to be basically what we're going to spend some time talking about today. We're going to be doing a lot of things where, especially some of these cast parts, you can see that there was some milling operations that happened after the rough casting or after the additive manufacturing potentially. And so what we're going to do with the selective surfacing tool is we're going to find those areas and we're going to add some stock back in, right? So we're going to modify the mesh so that before we auto surface it, we have a mesh that's more representative of that part prior to being milled. Just as a rough casting or a rough forging or rough, whatever generative design tool is. And then we're going to go mill those features back into the final CAD file virtually. So I'm going to go ahead and get rid of my death by one PowerPoint slide, whatever, and go into Design X. Hopefully I didn't make a mistake and only shared the one screen. Can everybody see Design X okay? Wait for a couple comments here.
Yeah, you're all good.
Perfect. All right. So this is not, all right, just got a black screen there and came back, so that's good. So, this is a file that I've already imported into Design X, and I've run the region group command on just because it takes a couple of seconds, and I don't want to wait for that during a webinar. But otherwise, it is just a raw scan, right? So it is volumetric, at least. This is pretty, devoid of holes, at least. It looks like it's basically watertight. So it's almost ready to be, or it would be ready for auto surfacing, but there are a couple of areas that I do not want to model with the auto surfacing. One of them is going to be this, this tapered kind of pin down here where the ball joint stud, or I think it is the ball joint stud is the proper name for that. That is obviously a prismatic feature that will, eventually drop into a tapered hole in some sort of, axle or control arm or something like that in a vehicle. So that needs to be, I'm going to model that with more prismatic tools. And then these mating features up here as well are going to be the same thing, right? I've got these 4 holes that I'm going to, I prefer to model with a cylinder that I can dimension and I can place exactly where I want it to be rather than just shrink wrapping surfaces over it. So what we're going to do is we're going to use selective surfacing to remove basically those 2 areas. Before we do that, of course, though, this is a part that is not oriented to the world, right? If I use my standard Alt 1, 2, 3, 4, back, front, left, right views, etc., it is not oriented to the world. So, just good practice with any file inside of Design X is to orient the file to the origin before we do any modeling, right? So I'm going to show my regions here, and I'm going to, see if the align wizard can work for me, right? Tells me it's going to put an origin right about there, and I can see my front, left, right, top planes, etc. And it looks pretty close, like on first view, but I think it's not perfect, right? The Align Wizard tool is great. It looks for patterns in the regions, and it tries to orient the scan data to the origin without really any manual intervention on my part, but it's not always right? Just kind of it depends on the region groups as it sees them. So it definitely found this stud, and it found a plane to kind of mate that with, but it wasn't able to find the kind of mirror plane here that I was more hoping for. And there's a couple ways that we can do that. One of my favorite easy ways of doing an orientation or alignment in the software is to just use the same tools that we use for modeling, right? If I go right into my sketch command here, I can go ahead and fit a couple circles to those areas, and then I can start creating some construction geometry between them, right? So if I create a line between those 2 circle center points, these 2 circle center points here, then I can find, if I hover right over the center of that line there, you can see I get a midpoint constraint pop up. I'm going to create a midpoint constraint there and to this other line. And so now I've got something that can become like my y-axis, maybe something that can be my x-axis. And since they're on a plane, this point will then become my origin. So really quick and dirty way to do an alignment to the origin. Of course, I'm going to use the interactive alignment command, same way with sketches as I would with reference geometry or regions or anything else, right? And I'm going to tell the software that my origin position is going to be that point there. X-axis is going to be that. Y-axis is going to be this. And you can kind of see the right-hand side here, that preview moves around to show me where the actual origin is, or how the orientation from the part to the world looks. And if I go, accept the results there and then run through the same commands I was doing before, that looks better, right? And then of course I can always validate that by going back and then just, creating those same sketches again, making sure those lines are vertical and horizontal instead of kind of askew like they were. Since this sketch never moved, it's always the scan that moves when we use either the interactive or align wizard there. I'll go ahead and delete that sketch because it's on a plane. It's not useful for me anymore. And now I'm basically ready to start modeling. So let's go over to the exact surfaces tab, open up my auto surface command. And this is generally a mechanical part, so I'll leave that. In this case, there's definitely a lot of areas that were probably sand cast or forged. Kind of tough to tell with the scan data, but one of the two. I'm guessing probably forging with this kind of flashing in here. So we're going to definitely want to model all of that with auto surfacing because that's maybe not the most prismatic, maybe not the easiest way to get a nice tight accurate model to quickly. And then I'm going to do this boot as well. Would I actually care to have CAD of a boot in this, in a real world scenario involving this ball joint? I don't know. Probably not. I mean, it's nice to have a representative model sometimes and kind of understand where things are spatially, but functionally having CAD of this isn't really all that important. But for the purpose of the demo, I think I'm going to stick with it. So what I'm going to do is I'm not going to touch any of the normal auto surfacing commands that we're used to seeing, right? Everybody's probably used this tool before, so that's a little bit old news at this point. What I am going to do though is click on this selective surfacing option here, right? So selective surfacing, not a new tool. We added this in Design X 2020. So anybody, even if you're not current on maintenance in 2023, if you have an older version, 2020, 2021, 22, whatever, you'll have this option here. And essentially what this is asking me is what of this mesh, what part of this mesh do I want to auto surface, right? And I can segment or carve up the mesh in a couple of different ways. The first way that's pre-selected here for me is using boundary curves, right? So if I had some 3D mesh sketches and I drew a little, patch or something like that, I just kind of sectioned off an area of the scan data here, it would infill only that area with the auto surfacing patches. And since I don't have any boundary curves, what I'm going to do is I'm just going to pop open the help. And if I scroll all the way down here, you can kind of get a sense of what that looks like, right? So there's a mesh that continues beyond this curve here. And so in this case, this colored area here, this orange, and you can see the regions back there, that will not be surfaced. And then everything in this kind of highlighted blue color here, that electric blue, is going to be surfaced. There's also an option here that says flip trimming region. So if the software decides that it wants to surface the wrong portion of it, right? So if I draw a little patch here and it's trying to surface everything outside of that patch rather than inside of that patch, we have a flip trimmed region option. You can kind of see what this looks like again in the documentation there. Go ahead and close that. I'm not going to use boundary curves. I am going to use mesh selection. So when I change that, you can see my input box here changes to polyface or region. As you saw already, I have regions, and regions are probably the easiest way to work with this command, or at least in my opinion. So what I'm going to do is, first of all, just hit Control A, right? And that is going to select my entire mesh. So I think in this case, the stuff that I am going to auto surface is more than the stuff that I'm not going to auto surface, or the portion of the mesh that I'm not going to auto surface. So what I'm going to do is I'm going to select everything, and then I'm going to start deselecting some stuff that I don't want, right? So in that case, now, right, I can hold the Control key down and I can select some stuff that I don't want there, but I can also hold the Control key down and just deselect a region, right? And so if I don't want to do an entire region, it's a lot easier to deselect an area of mesh like that. I can also come in here and deselect that little fillet. There's also a really nice tool that shrinks the selected region, which I'll get into in a second here, that kind of requires me not to go through and find all these tiny little regions, because we know that region groups can be a little bit of a challenge to work with sometimes, or they're never perfect, right? So I've deselected that stud. I'm also going to come up here and deselect the chamfer and each one of these holes. It's going to take just a couple of seconds for me to do that. And you know, the workflow that I'm trying to accomplish here is certainly possible without selective surfacing. I don't want to ignore the fact that this is, you know, not the only, you know, and there's basically everything in Design X. There's more than one way to skin a cat, more than one way to perform an operation. The reason that I like selective surfacing, especially for users that, you know, maybe aren't as familiar either with Design X or just polygon modeling or editing in general, is that, you know, anybody can select regions. They function very similar to CAD faces, and deselect regions and kind of work with data like this. So this prevents me from having to do a lot of hole filling, to have to do a lot of polygon editing, to do a lot of other things. It may be quicker, you know, experienced user like myself, I might actually be able to run through this faster, just kind of copying and pasting and modifying meshes and auto surfacing and going from there. But for the, you know, the general population out there that's using Design X, they're probably not spending quite as much time as I am in it. So this is a really good, maybe not efficiency tool, but kind of a quality of life tool for them. So, all right, I've got everything that I don't want to be auto surfaced deselected there. And just as a bit of a sanity check, I want to see, oops, I accidentally missed a chunk of the mesh there. So if I turn off the mesh, I can see what is actually being used here. And that's kind of a nice thing if I am missing an area like that. So it's very, very useful to have that option to get rid of. So the reason that didn't happen is when I hit Control and deselected a lot of this stuff, I didn't have my visible only on. And that's what I get for trying to talk and model at the same time. Anyways, it looks like we're all ready to go. So what I'm going to do is say, okay, we're going to fill all holes. So I know that there's going to be some holes in the mesh, right? I've kind of made them myself. So if I want to fill those holes, I can choose to do it with flat triangles. I can also choose to use this shrink region depth that I talked about before to back my selection away just a little bit. So you can see what happens here if I increase this region depth. So if I go to like 3, it might be a little bit easier if I turn my regions off. You can see this orange bound region, right? So I didn't deselect these triangles. It's basically sucking back the selection. If I can do like 5, come on. Oh, numlock, that would be helpful. There we go. So if I increase that selection there, it's going to delete all of these triangles instead of just the ones that I deselected that way. So this kind of helps smooth things out a little bit. I'm not going to go quite that much. I'll do a 3 there just to get rid of any triangles that like maybe kind of folding down into one of these regions. It doesn't look like I have any issues with that here, but it's just always good to back away your selection just a tad. And so then the rest of the process looks almost identical, right? So if I hit next stage in the auto surface, it's going to basically take all of the stuff that I had selected still, all of the, you know, the rubber boot and the forged part and everything like that, minus the holes, minus the studs. It's going to copy that into a new mesh. And then it's going to fill all of those holes. And then that mesh, so auto surface mesh 1 is now created in my feature tree here. So auto surface mesh 1 is just that, basically what we would call a defeatured mesh at this point, right? So the cylinder features and that stud feature have been removed. And now this file is ready to be auto surfaced. And the auto surfacing process looks exactly the same from this point on. So I'll just go ahead and run it. I assume this thing is surfaceable. I think when it creates that new mesh, it actually runs the healing wizard as well, because that's a pretty critical step before auto surfacing. And since we know that's where this file is going to go, we run the healing wizard as well. So wait about a minute or two for this to complete running. And what we should hopefully see in the model tree down in the bottom left-hand corner here is we get a new group that says solid bodies, and then auto surfacing 1 is that solid body that's in there. So take just another second here, and then we'll get back at it. While it's thinking, I'm going to drink some coffee. not a terribly huge file, about 800,000 triangles. So should be a sub 1 minute auto surfacing. So I do have a live transfer warning coming up here. I probably should have turned that off before I did the webinar. Live transfer warnings, if you're not familiar, are found in the error list down below. And right now I've got my Design X set to tell me that anything, I make something inside of the history tree here that is not compatible with Inventor, since Inventor was the last program I was doing live transfer to, it will give me a warning like you just saw in that pop-up there. And that warning was for the auto surfacing, saying that this feature can be exported to Inventor, but it can't be edited there, which makes sense, right? Inventor doesn't really do much with meshes, and it does not have an auto surfacing command, so I can't edit the auto surfacing anywhere else other than Design X. But of course, I can get that CAD body there and do whatever it is that I'm going to do with that CAD body. So, like I said, I do have a solid body here, which is exactly what I want, and we would expect, actually, since I'm on a webinar, I'm going to go ahead and say just because that's probably a good idea. There we go. So yeah, since it was exact surfacing, I should expect that the deviation overall is going to be fairly minimal between the scan and the CAD, which is exactly what I'm hoping to see. So I'll turn that off. And the nice thing about this workflow, if I compare this back to doing everything manually, used to be I just have to, either copy an entire mesh, paste, and then, do a lot of mesh editing there, or end up having to, if I forgot to do that, I'd end up having to bring the original scan back in so I could reference the positions and locations of the holes and the other stuff that I've removed. With the selective surfacing, since we create that mesh for you, we can hide it and revert back to our original mesh. It's still in the exact same position it was, so I can overlay that now over the CAD body. And if I go back into my sketch mode, we'll go ahead and create a sketch to find the location of those circles there. And let's go ahead and punch those in. So you already saw me do this once for alignment. This is not rocket science. I'm just best fitting some circles to that area of the cross section there. And then of course, since this is Design X, and since we're probably going to go to somewhere downstream to CAD, it's probably worth creating some constraints, right? So equal radius on all 4 of those holes if I want to constrain them that way. This is definitely something that we couldn't do if these holes had been auto-surfaced over. So one major benefit for working with feature modeling. I can also do smart dimension too, right? So if I want to say this is probably not intentionally a 10.93 millimeter hole in diameter, I can just override that to be 11, and now all 4 of those holes are 11 millimeters. And of course, I can set up all the rest of the reference geometry and constraints and relationships and stuff like that to fully define this sketch. In the essence of not spending a whole bunch of time on the webinar today, I'll go ahead and just kind of leave it as is, but then of course, we can punch those holes out of the CAD, right? So using just a normal extrude, go in the opposite direction, cut, done. And so that is kind of that blended, this is now what we would consider a hybrid model, right? So I've done some feature modeling on it on the things that I want to control. I've done some auto surfacing on it on the areas that I'm less interested in trying to make any changes to. And that is the final model there, basically. I can go add that stud, but it's basically the exact same workflow as before. And if you are curious, I've got a great video on my YouTube channel on how to model threads, and I think we might turn that into another full-length webinar again in the future. But as far as I'm concerned for the day, that's basically how selective surfacing works. Again, it's a really nice mode, especially for people that aren't used to spending a bunch of time editing and cleaning up polygons and getting everything dialed in so that the auto surfacing works or whatever. It kind of just takes care of a lot of that for me. So I'll go ahead and turn it back over to Guy. I think we managed to knock it out in a tight 25 minutes today, and happy to listen to any questions and answer what I can.
Great, thanks, Sean. Yeah, really good presentation. It's a really cool tool to watch in action. It makes me want to get my hands on the software a bit more. Has anyone got any questions for Sean about the selective surfacing tool, about Geomagic, about his day in general? Pop them in the chat. I'll give everyone a couple of minutes to have a think.
Or we can expand that to snowboarding or motorcycles or whiskey or any of my other interests too. It's really up to you.
All good. If there's any questions that you think of, if you want to review the webinar again, want to share it with your friends, if there's anyone that you think would benefit from seeing this tool in action, you will receive an email after this with the on-demand video. We'll be sharing it on our website at some point in the next couple of weeks as well. But I appreciate your time. Hope you found it useful, and we look forward to seeing you next month. I can't give you a presenter yet, but rest assured we'll have another great workflow. Thanks, everyone.
Yeah.
Have a good morning, afternoon. Thanks, Sean.
No worries. Yeah, let us know if there's any other topics that you want us to cover. I know we've done some webinar series in the past. That was years ago, so there's a lot of new stuff to talk about, but of course we want to make sure that this is as relevant to as many people as possible. So feel free to reach out with some suggestions for future content. Until then, though, I appreciate everybody's attention, and yeah, have a great rest of your Wednesday.
Thanks, everybody.